Okay. Good afternoon. Thank you for coming. It would be kind of weird if it was just me and Marcelo. Okay, so sprinkling Wireguard with Volt and Marshmallows, it's the name of our presentation. And we have split this presentation within kind of 6 chapters. We'll speak a bit about us, the state of affairs that led us to this, a simple storyline just to explain the concept. Then we have a story to kind of illustrate what we did, and then there's the backstage and future work. So about us.
Hi, my name is Marcelo, as you can see. I've been a software developer in the past. I failed. Kidding. I turned site reliability engineer, and it's what I do in the current times. And
okay. So my name is Sergio. I was a network engineer, software developer, security engineer, and I'm currently a security engineer. So, state of affairs. How we got here. So, we work in an organization that, as many, has some form or another of remote access. And our current VPN solution kind of answers the company main requirements, but it has some kind of constraints. It's not bad, it's not good, but it does the job. However, there's one small problem with our solution is that users hate it and the user experience, and so kind of the potential for insecure workarounds is really big. And usually today, especially, it's easy to kind of pop a new instance in the internet and try to access resources that should be private and that are then somehow publicly available in the internet. And so this is a big problem for us. So one of the complaints was connection instability. We work in a company that is really remote friendly, and this means that users change networks a lot. And this leads to kind of instability problems within the networks themselves. And by moving around, the VPN connections tend to kind of fall, and people need to re-authenticate. And this part of the authentication is another one of the problems. Because we currently have kind of a quirky two-factor authentication solution. Having a two-factor authentication solution is a kind of good thing, but our current solution is not that great, and the authentication process really takes forever. This leads to kind of developers losing a lot of time just trying to reconnect. And so this was kind of a problem. So we started asking for help, looked for another option. We learned about a recent system at the time that would be probably included in the Linux kernel and works like a kernel module, and it had lots of tech goodies and crypto shenanigans that we thought it were really interesting. And there came Wireguard. This is kind of the marketing lingo from the website if you want to check it out. Simple and easy to use, cryptographically sound, minimal attack surface, etc. So it seemed promising. However, there's one problem that's usually when trying to operationalize this kind of stuff, which is key management. And this is spread out across all the technological parts of maintaining an infrastructure securely. So we kept asking for help. And then after asking for kind of what exactly were the pains of the users again, and not trying to reinvent the wheel and using kind of stuff that we already were using within our own infrastructure, and we wanted something to be easily integratable. So there came Volt. And this is, I don't know if anyone does not know Volt, but it's kind of a product from HashiCorp. And these are the kind of the features, the main features of it. Secrets management, data encryption, identity-based access, auditable, and it's easy customizable by plugin architecture, which is something that we'll explain later on. So many promises. Okay, let's do it. And this is the storyline. Too much storyline. Okay. Yes. The storyline is just for us to make it easier to explain what we did and how it kind of created the problem or explained the problem that we have. So there's a cast. In the cast, there's kind of continental members. There's Winston, Sharon, the hotel manager. There's another part of the team, which are the curators, the administrator, curator, adjudicator, Addy. Then there's the Seclorum, also known as the High Table, composed by Vigo, Binksy, Velos, and Innocencia. And there's Mr. Wick, obviously, with his puppy. And there's the problem, the puppy. So this is kind of the set. We have the user, and this splits in two parts. One of them is provisioning the keys for the users. That part can be done kind of without being connected to the internet. And you can provision all the keys in Vault. And the other part is for the access itself. And for us to access these particular resources, so the puppy and the high table, you need to access the accessor or the VPN, which is connected to the internet, that one. And that's it.
So, talking about the storyline, we start by having a user that wants to reach the protected resource, and for that, he needs to require the blessed account to do that. Someone needs to provide that blessed account, and then the user can actually access the protected resource. Later on, the key it's considered compromised and will be revoked. So the treat model. The generic individual, it means the one doesn't have access to the VPN, cannot detect the VPN service because it's hidden, and cannot impersonate any member. The member of Continental, so it's a simple client, can view, it's like an auditor guy that can view the access logs and can view who is provisioning that keys. The curator is the typical client. He can view the access to iTable, can provision new members, and can change public keys from his members. His access is detected, and the changes and may fails to revoke that keys. The member of the Seclorum is the administrators. He can view the access of iTable, provisioning keys, changing keys of other members, and revoke access. He also can change the server configurations. Of course, all of these previous operations are logged and can be detected. So, getting the puppy. Mr. Wick has a puppy and taken by the members of iTable Council, and the puppy lies in a special chamber protected by a cyber stealth hardened post-quantum mechanism of desktop, controlled by the iTable. And at this time, it came to hotel manager to talk.
Mr. Wick, how may I be of service?
I need access to protected resource under. I need access to resource under protection of iTable.
You need a blessed account.
I understand where I can acquire one.
It is not something that you can acquire.
Very well. Who has one?
Well, Mr. Binksy. Mr. Wick uses his special charm to earn the right to own an account, and the way the system is set up requires a new key to be registered. Mr. Wick, politely asks for Mr. Binksy to provision his account, his new key.
And then this failed because... Just a second, because internet failed.
Because internet, yes.
Damn it. It happens. It's not a real demo and it failed. What? Just give me a minute, sorry.
The internet will return in a moment.
Hopefully.
Yes.
Connected. So, back into the movie. Yes. Work. At this time, the guy that needs to access the resource needs to provision a key for someone that can put his key on the server. That means Mr. Wick needs to send his key to an administrator or something like that. This is what happens here. Since it's a public key, it can send through open internet like an email or other mechanism like copy-pasting, that what is happening here. At this time, Mr. Binksy gets the key of Mr. Wick and put it on Vault. It's allocated an IP for Mr. Wick, and the configuration is updated without compromising the current connections on the VPN. This is what can see here. Here, Mr. Binksy will start by logging into Vault. Very secure password, as you can see. And you can see that it's a guy that has admin privileges. We're going to see this later on, this policy. You can see we have a token duration for 8 hours. So this means that with this token, you can do all the operations on Vault during 8 hours, starting now. And then, using the previous token, you're going to put the Mr. Wick key on the server. This will generate some configurations on Wireguard server and returns a templated configuration to be used by the client. As you can see, we have the IP that client will assume. It's 172.16.1.2, and we have expiry time for that key on server that will be on the past. It's already happened. And also we have a templated configuration that client can copy pasting and use to connect to the server. So this is what happens next. Mr. Wick gets that configuration, put it on his computer, and access to the protected resource. Copy paste the templating part, updating the client. He needs to replace the private key field with his own private key that generated the public key that is sent to Mr. Binksy. And after that, we'll be able to connect the server. Typo there? No. And then, at this point, Wireguard is configured and is able to reach from client to the server. And reach his puppy. That's what he wants. As you can see, we have connection to the server where is the puppy. So, moving forward. What? Damn it. Let's do visual. So, moving forward.
While Mr. Wick moves forward with his endeavor, the nullification of Mr. Binksy does not go unnoticed. And so the high table housekeeper reads the accessor logs, and there it is, Mr. Binksy with a brand new public key. This was unprecedented. Mr. Binksy was emotionally attached to that key. The housekeeper then understands who may be behind this behavioral change, and he is an old acquaintance of Mr. Wick. Therefore asks for the presence of the most capable high table servants, and, well, Mr. Wick has valid arguments. His puppy is now safe. Behind him, a pile of corpses lie on the tapestry that welcomes newcomers to the high table. And the high table declares Mr. Wick excommunicado yet again and revokes all of Mr. Binksy's accesses, which leads us to...
And this is what happened here. Someone from the administrator part, the Seclorum, revokes the access of Mr. Binksy. You will be able to list the current deployed keys on Vault that is also deployed on the server via Vault by listing all the clients. We only have one for this proof of concept, but we can have multiple ones. As you can see, it was a key that was provided for Mr. Wick by Mr. Binksy. and then revoke the key. Or delete the key from Vault. That will be deleted also on the server, Wireguard server. We could do it faster. So no keys on the server right now, and checking on the server, there's no more peers to be connected. Well, also we can check that client is not longer able to connect to server to reach his puppy, or the puppy is no longer there.
So, since his access is revoked, it really doesn't matter because Mr. Weak doesn't care. So you can have the best of breed security system, but you cannot get between Mr. Weak and his puppy, as we all know. So, regarding backstage. Backstage is, we are going to explain each part of this story, which is the fun part. Yeah.
Okay, starting by the Vault. As we previously mentioned, we are already using Vault to do some secure parts on our network by generating tokens, database credentials, and other fun stuff that Vault provides us. But why you are using Vault? Because of the goals that is being designed for Receive. So it needs to be a single source of secrets. These secrets need to be programmatically easily accessible and needs to fit on a multi-data center architecture that directs us to the multi-cloud trendy world that we are living today. This means the Vault does not need only to be compatible with multi-cloud providers, but needs to provide a secure way to transmit data between those data centers that we can call in a secure manner. And also needs to provide access control and provides also practical security above all the system. So, regarding the features of Vault, he provides dynamic secrets that previously mentioned, that like PK certificates, SSH certificates, database secrets, and so on. He also has ability to write rich SCLs programmatically. That means that some resources only can access specific parts on Vault and others the same. And this is very important because if one of application is compromised, he only able the guy who compromised that application is only able to reach the secrets that application is able to read. This is very good because as many secrets you know, it's better. And it also offers flexible authentication and auditing overall. Regarding the secure secret storage, all the data on Vault is encrypted by saying all the data is the data that it's at rest and in transit, using TLS 1.2 for communications, for transport layer between the clients and Vault, and encrypt all the things with 256-bit using AES in Garlock counter mode. This is quite faster than the usual cipher blockchaining, and this also provides authentication by default. Vault also uses an algorithm called Shamer secret sharing to build a master key that encrypts all the data. This it depends on the configuration, but for generating that master key, you don't need all the parts or all the shards of this secret sharing, but some parts only to rebuild that secret key. Also, the very important part, the leasing and renewal revocation. All the secrets on Vault and tokens has a lease time that can be renewed or revoked before the lease actuate. Also, the auditing. Vault logs everything, logs all the requests and the response, but does not store the secrets on logs. At some point in time, we already seen applications that do that, but this is not good, as we know. And all the secrets are hashed. This means that they are searchable, but cannot be reversible decrypted. Also, we can plug as many backends we want. because this is very good because we can also have a backup of the auditing, but we can also compare two logs to see if one of them has been tampered with or not. It also prioritizes safety over availability. This means that if Vault cannot audit or log something, it won't return the response. It will fail before. And finally, regarding the authentication, Vault offers multiple backends for authentication, like tokens, OpenID, certificates, user password, to be very easy to use by machine-oriented like applications, or be user-friendly too.
Yeah. Regarding Wireguard itself, so the motto is to be an extremely simple yet fast and modern VPN that uses state-of-the-art cryptography. And these were kind of the things that led us to think Wireguard was a really neat solution, although it states that for the time being is not production ready, but the design principles are close to our heart, let's say. So it's easily auditable. It's supposed to be simplicity of interface, the static fixed length headers, static guarded state allocations and guarded states, stealth, solid crypto, and abuse resistance. And we'll explain a little bit about each one of those. So it's implemented in kernel space, so you don't have kind of the problem of being an application in user space that has a lot of context switching, which makes it also very fast. It's highly opinionated. This means that, for example, OpenVPN or IPsec can have a lot of configuration for cipher suites, etc. Not Wireguard. Wireguard kind of really restricts your options. There are basically none. What you get is what it's out of the box. And this has obviously advantages and disadvantages, but statistically speaking, I think the advantages overcome the disadvantages. It's a real layer 3 only solution, and this has also advantages, like we'll see a little bit later. It has less than 4,000 lines of code, and this enters in the part that I was speaking before about being auditable. That is the kind of the footprint, the line of codes are few, so it's easier to kind of audit the code itself. And it's operationally coherent with common networking tools, reducing operational vulnerabilities. What does this mean? This means that this is kind of one of the principles of when this component was built. And what this allows us to is to have kind of that part there of simplicity of interface. And so the persons that are currently kind of managing the servers or managing the network don't really need to understand thoroughly, for example, for all the options that IPsec provides you to, or even OpenVPN about certain configurations, because it's given to you out of the box. Also, regarding crypto, Wireguard really takes advantage of the noise framework, which is used also in other stuff like WhatsApp and Signal, etc. This allows it to be kind of the one round trip for key exchange, and it uses curve 2519 for the points for building the public keys. Using elliptic curve Diffie-Hellman, and it uses for the symmetric crypto part SHA-20 with poly 1305 through the encapsulation of encryption of the UDP packets that are encapsulated. Wireguard uses UDP, and it uses Blake 2 for hashing, and the public keys themselves, because it kind of builds a routing table around those public keys with the targets. Use a hash table that takes advantage of the function of ziphash2 for Mac. This also intends to be really fast and so not vulnerable also to collision attacks. And it created a new crypto key based mitigation for DOS attacks. This is not kind of a new idea, but they create kind of a different protocol for building this crypto cookie. And one of the properties interesting in this particular protocol is that Wireguard deals with both endpoints, the initiator and the responder. they both can interchange roles, and that means that, for example, the way the crypto cookie is built is in order for not the client or the initiator cannot DOS the responder, and the responder cannot DOS the initiator. It also has one particular property, which is no resources are allocated for unauthenticated packets. This goes into that also part of stealth. So, for example, if you have a network scanner and you don't send authenticated or valid packets to Wireguard, it will simply drop your packets and it won't answer you. And it's during it has kind of a 2-minute session that it rotates the session keys for the VPN session itself, and it provides PFS or perfect for secrecy with this. It has one very important property that it takes advantage of, which is crypto key routing, and it connects kind of the public key with the IP address, the one that we were seeing before, and this is kind of tightly coupled, cryptographically tightly coupled, and so this is an interesting property that it takes advantage later on, like we will also show one advantage of. And this part of the routing enables that solving the problem that we mentioned at the beginning of being kind of unstable connections, because it has the capability of roaming the connection between. It's similar to Mosh, that's why it's explained there. And this means that, for example, if we have a VPN connection now at this moment, we can close this laptop, imagining that it had a Wi-Fi connection here, and we go home, open the laptop again, and we would still have not the same VPN connection, but it would automatically be established with new session keys. So this is good to dealing with mobile users. And then for all this to be possible,
and then we developed a plugin that integrates Vault with Wireguard. For that, we also do that. We established some goals that plugins need to be able to solve us. Those goals are needs to simplify the Wireguard configuration even more. By simplify the configuration, it means for the server and for the clients. And it also need to revoke the access and auditing all the connections. So the features of the plugin, we want to add peers dynamically on server, establishing TTL for those keys, and build a simple DHCP server that we can match the IP with the public key and get that matching information. We also want to provide the configuration for the clients so we can easily connect to the server. So we define 4 endpoints for the plugin. The admin part that will provide administrator parts like deleting keys or auditing the keys that are deployed on the server. The client part that is for the client interaction to send public keys for Vault, and after that those keys be used on server. The configuration part that is for configuring the plugin, like establishing the CIDR block of the net that Wireguard will use, the TTL of the keys, and the public key for the server, for example. The private key and the private key is stored on another part, but the public key. And the server part that will be used by the server to read the keys and create interfaces on the server, the Wireguard server. We also use console template to read those values from the Vault and deploy the server configuration. So the process is client writes to Vault, console templates reads from Vault and writes the configuration Wireguard, then reloads it. And finally, the user can access Wireguard. This is the process where we install the plugin on Vault and enable it. To do that, we use another super secret token to do that. Remember, this is only a proof of concept. Locates the plugin, and for this case, we are under Vault plugins, and install it by providing the SHA-256 of the binary to be registered on Vault. This is very useful because if this binary is tampered, Vault ignores it after that, and this is good because we cannot do changes on binary to do some bad stuff. This is the aspect of the help page for the plugin with the endpoints more detail, and we talk more detailed about the endpoints. The two ones are the admin part. The first one is for listing the keys, and the second one is for reading the details of one specific key. The client already told it what it is. It's for the client to write this public key to server. The configuration is to write the configuration of server, and the server is for listing, and the last one is for reading the key also. On Vault, we also installed some policies that disable or deny some clients for reading some paths on Vault. Sorry, I mean deny, but Vault denies by default and only allows on this specific policy. This is used by admin. That means the admin can do everything on the plugin path that's VWG. This is the client one that is able to write his only public key, because it's only have an allowed parameter to write to the client path. And this is a read-only part. The read-only part is, for example, this is an error right there, because it's not should be read. This should be on server, but it's only to read. It's like an audit guy that comes to Vault and check what is the configurations and the clients that are deployed at that time. And WG server. This is where server use for read the public keys and provide the provisioning the configuration. This is an example of the right configuration where we establish the time to live of the keys, the CIDR block of the network that Wireguard will use, and this CIDR is used for the DHCP client generate new IPs for clients. We also provide the endpoint that will be used by the endpoint and the public key that will be used by the clients for the template part. This is a video with the public key. I think I'm gonna bypass because we are running out of time. And this is a client example where the client sends this public key to the server to be used and templated on the server. And this is an example of the return response when the client sends this public key to the server. As you can see, we have the expiry time of that key, the IP address that will be used, and a templated configuration that client could use later on and put on his side to connect to server. We also can do some pipe magic and generate dynamically our private configuration by generating a key, piping to Vault by generating our public key, and do a set after that and use the generated response. On the server side, we are using console template, as we mentioned previously, to generate the configuration, and this configuration will list all the secrets and read every secret to put on the server. This is an example of the configuration generated that have all the peers connected to the server and is associated public key.
So one of the parts that we wanted to ensure was that we had accountability by the usage of all this kind of solution. And so audit was an important part of it. And so we wanted to keep a detailed log of every interaction with Vault, and with some specific exceptions, like Marcelo mentioned before, all strings are run through an HMAC. And this means that when it's written into the audit logs, you really and unless you know the secret, you do not understand what's in the audit log. And this is provided by default by Vault. However, you can still search for some string that you know. For example, if you know the public key, there's an endpoint also in the Vault that returns you the value or the calculation of that HMAC with the secret that it's within Vault. And so you can use then that image to search into, for example, the example that we did was we placed everything in Elasticsearch and accessed it via Kibana. And in this particular case, only the deletes appears there with the public key, but the updates and the creates, etc., you would need to do that part of the flow. That is to calculate the HMAC of the public key and then search for it. Then this is part of the problem. So this is the kind of the part of the provisioning of the keys themselves, but then you get the access to the VPN. Like we explained before, Wireguard is a kind of layer 3 only solution. So this enables kind of other stuff. And since we have kind of this strong cryptographic mapping between the client IP and the public key, we can use common IP monitoring tools like any other tool that's usually people use for networking stuff. These are kind of two examples, Nightflow or IP tables connection tracking. And since it was easier for us, we just did an IP tables with the logging of these particular connections. That's everything that goes through that virtual interface, network interface of WG0 created by Wireguard. We can simply log it and understand which clients connected to where at what time. And this is only, for the example, there's only one connection, or one client, one server. So this is kind of boring, but it's just to make a statement that it's completely possible and easy to do. Again, this was using Elasticsearch and Kibana to reach that part. Wait, sorry. And there we go again. Wow, amazing. Okay. Future. It's the future.
So regarding the future work, we want to enhance the documentation by writing Go docs on the plugin, because this is written on Go. I think we didn't mention, but all the plugins on Go for Vault are written on Go, because HashiCorp provides an awesome SDK with all the abstraction for that. We also want to open source the plugin so community can know using it, and build a alarmistic on top of audit logs. We also want to improve the test coverage, and later on we want to enable that only a specific user will be able to provision his own key. This is a bug that we have right now. And where are the marshmallows? Like we promised, there. And this is a video of the full process. No? He won't play. Okay. Questions? No questions? Time for beer, right?
One question over there.
One question?
Who's going to make the question?
I think there's one question.
Hi, do you support private keys stored on some cryptographic tokens, like on smart cards or TPMs and stuff like that?
No, for the time being, no. Unless Vault do that, we not do those things on the plugin.
Yeah, no, but that's given to you by Vault itself, because Vault has an interface for HSMs, for example, using PKCS11. So if you want to, you can just connect that to Vault. But what we thought was interesting for us, at least because we use Vault, was that you can take advantages of all those properties that Vault provides you out of the box. So, but this is for the part of the private key of the server. For the client.
Yeah, I was asking regarding the Wireguard, regarding the VPN connections, like
from the client side.
Yeah, from the client side.
Yeah, but the client side, it's whatever you want. Like you said, you can store the private key in a smart card, or the important part when kind of the creator of Wireguard, what he wanted was to make kind of the parallelism with OpenSSH, and so whatever solution you have for OpenSSH, you could use for Wireguard.
Okay, so you are just using public-private key pairs without wrapping it into a certificate, X509 certificate?
No X509s.
Okay, and why was
the key itself? That's one of the things at the beginning that it uses the curve 25509 for taking the points from that curve so that you can have a 16-byte public key, but not with X509, because that would mean a lot of different problems, and not like OpenSSH. What you want is kind of something very simple, and that's the purpose of
Okay, thanks.
Okay.
Any more questions? Thank you. One more. Who's there?
No.
That one and here.
Yeah. This one first, please.
Yeah. Oh.
Hello. So how do you deal with high availability of Vault? In terms of the Vault implementation, do you use enterprise version or?
No. The question is, for the time being, we are using only the open source version. We deal with the high availability. We are dealing with console for the backend storage.
Okay. Thanks.
Here.
Hi. So I saw a lot of IPv4 addresses. What's your IPv6 readiness?
It doesn't matter, because it's a layer 3, so whatever you put in IPv4, it's the same for IPv6. It really doesn't matter.
Yes, our POC is only on IPv4. It also works.
Yeah, it's only our proof of concept is in IPv4, because we are old school and we want the internet to burn. But that's only it. It has the capability of simply creating virtual network interfaces on the box, on the operating system, but it's not connected to IPv4 itself. It doesn't matter. Whatever the operating system gives you, it's what it can use.
Right. And another question. The key generation and then putting the public key in the vault, that looked a little bit like a certificate signing request. In a public key infrastructure setting?
In the example that I give you, so this problem is exactly the same problem with anything else about public keys, like OpenSSH.
You are talking about,
for example,
this example, right? You are talking about this?
No, any example about putting their public key, right?
Yeah. Distributing public keys.
Yeah. So at the beginning, sorry about this for anyone with problems about spinning stuff. So whatever you can do, whatever you want. But here, for example, what it's trying to kind of illustrate is that you can use kind of a trusted environment to store or to provision the public key of the user. Okay.
Right.
But the other possibility is, for example, if I already trust another public key that you have, you can send me kind of a message encrypted with your PGP key, and I can open that because you can send me because we have a trust relationship, right? So the important part is to have a kind of a trust environment where you can share those keys.
But since it's a public key, it doesn't matter, because only the owner of the private key can use that connection.
Sure. More questions? No? So, thank you guys. Now there's some beer and food.